A message queue is a system that allows different parts of a software application or different applications entirely to communicate by sending messages in an organized, reliable way. Instead of sending messages directly, messages are placed into a queue where they wait until the receiving system is ready to process them. This helps systems stay efficient, stable, and flexible, especially when tasks happen at different speeds. Think of a message queue like the ticket system at a busy restaurant. Customers place their orders, which are the messages, and these orders go into a queue. Cooks, acting as consumers, take orders out of the queue and prepare them. If many orders arrive at once, they will wait in the queue until the cooks are ready. The key point is that the restaurant doesn't stop working if customers arrive faster than cooks can handle. Everyone just waits their turn. Message queues help computer systems work the same way. Why message queues are useful? Real systems don't always run at a steady pace. One part of a system may generate work faster than another part can process it. Without a queue, the slower part could become overwhelmed and crash. With a message queue, the fast part can keep sending work without waiting. The slow part handles tasks when it's ready, and no tasks are lost in the process. This allows the system to handle traffic spikes and maintain stability. 4 concepts. Term, producer, meaning, the component that sends messages to the queue. Term, consumer, meaning, the component that receives and processes messages from the queue. Term, queue, meaning, a storage area where messages wait until processed. Term, message, meaning, a piece of data describing a job or event, for example, send email to user. Term, broker, meaning, the server or system that manages the queue. The queue follows a simple rule. First in, first out, meaning the first message added will be the first one processed. Real-life example. Suppose you run an e-commerce website. When a customer places an order, your website saves the order quickly and sends a message to the queue. Send order confirmation email to customer. A separate email service listens to the queue. It processes each message and sends the email. This way, your website doesn't get stuck waiting for the email service to finish. The website stays fast, even during peak traffic. Benefits of message queues. Decoupling. The producer and consumer don't need to know about each other directly. They only communicate via the queue. This makes systems modular and easier to maintain. Scalability. If the system is under heavy load, you can add more consumers to process messages faster. Reliability. Messages are stored and not lost, even if parts of the system temporarily fail. Smooth performance. Handles bursts of workload gracefully without crashing or slowing down the entire system. Asynchronous processing. Tasks can happen in the background without blocking the main user experience. Popular message queue systems. System, RabbitMQ, description, general-purpose message queue with routing flexibility. System, Apache Kafka, description, focused on high-volume event streaming and real-time data pipelines. System, Amazon SQS, description, fully managed cloud message queue service. System, Google Pub/Sub, description, cloud-based messaging and event distribution system. System, Redis Streams, description, lightweight queuing built into Redis. Each one is optimized for different workloads and performance needs. Message acknowledgement. Most message queues have a mechanism where when a consumer processes a message successfully, it acknowledges the broker. If a consumer fails or crashes before acknowledging, the message goes back to the queue and is retried. This ensures work is never lost. Common use cases. Use case. Sending emails. How message queues help. Website stays fast. Email is processed in background. Use case. Video processing. How message queues help. Upload completes instantly while encoding happens later. Use case. Order processing systems. How message queues help. Work is handled in steps across multiple services. Use case. Logging systems. How message queues help. Queue collects logs without slowing the app. Use case. IoT devices. How message queues help. Devices send messages asynchronously to cloud servers. In summary, a message queue is a core building block in distributed and scalable systems. It handles communication between different parts of a system and smooths out workload spikes. It prevents failures caused by overloaded services and makes systems more modular, faster, and fault-tolerant. Put simply, A message queue is like a buffer that allows systems to send and receive work at their own pace, keeping everything running smoothly.